There we go. Okay. So I will be covering 3 sections in total, Nmap, Wireshark, and Scapy, but we'll do a video for each item. So that way it's all neatly broken down for you when you rewatch this later. The first one will be Nmap, where we're going to set up 2 systems. We're going to make sure that they connect to one another, and then we're going to do a little port scanning on both that system and a system that Sam has prepared. So first and foremost, we're going to use a Windows machine as our tester. On your Google Cloud platform, you should have a Windows and a Debian system, and this comes from our earlier section when we were talking about our cloud servers. Within the Windows system, we're going to turn off the firewall so that we can communicate freely between our Linux system and our Windows system. I do want to point out that in order for this to work well, you need to have both your systems on the same zone. So if yours looks like mine, where we have the US Central 1A, US Central 1A in both, you're good to go. Whatever zone you're using, it doesn't matter. As long as the 2 are in the same zone, this will work out just fine. So I'm going to share my screen multiple times. So if you're on your side, things look weird, I apologize. I am doing this on a 43-inch TV. That way I have plenty of real estate space to do everything. So I believe you should be seeing my Windows server now.
Yeah, it looks good, and the font is nice and big too.
Nice. So what we're going to first do is turn off the firewall, like I said. So in 2019 and Server 2016, you can click on this little button to search, and we're going to search for firewall. We're going to go for the Windows Defender Firewall with Advanced Security. This guy right here. And if you have any questions, please feel free to ask. I have the chat up so I can see any messages that come in. And what we're going to do is turn off the firewall. So by clicking on this, Windows Defender Firewall Properties, this last item in the overview, we're going to set the domain, the private, and the public profiles to off. Again, because these are virtual machines running on the cloud that we're only going to use for these items. We're not really using this for production. It doesn't matter that we're lowering our defenses. So I go to each firewall state, I set them to off, and I hit apply. You know the settings took effect because now the overview for these 3 profiles looks just like this. For Windows Defender, firewall is off for all 3.
Irvin, I've got a question about these Windows cloud servers. Why don't you just go back and show them where they can see how to make those if they didn't already make them?
Yeah, no problem.
Yep.
In Google Cloud, we can create an instance just by clicking on that upper button. That's in this top bar where we have VM instances. We have create instance, import VM, and so on. We're going to create an instance. It'll take a little moment. Once it's up, you can name it whatever you want. I'll name mine Windows 2. For this, for these labs, we don't need to change the CPU and memory. One CPU and 4 GB of memory is more than enough.
You need to change it for the Windows machine, though. We found that out last time. The Windows machine needs the second one, yeah.
Right. So and that's when you're using Windows more heavily.
Yeah.
For the items that we'll do in this lab, you can keep it to 1.
Okay.
But for other labs that we'll do further, we'll increase this to 2. So you could either increase it now just by clicking here and selecting 2, the N1 standard 2, or you could do that later when we reach those labs. We need to change the boot disk. This is what defines what operating system will be running on this virtual machine. So we'll hit that change button. Under operating systems, we'll select Windows Server. For all of our labs, it doesn't matter if you're using Server 2016 or 19. The thing that does matter is selecting a server with desktop experience. If you select any of the others, you will get Server Core. And if you've never seen Server Core before, it's a desktop with it's just PowerShell and nothing else, which is not necessarily ideal for the things that we do. So you can pick either the Server 2012 with desktop experience, the Server 2016 with desktop, or Server 2019. As long as it has server with desktop experience, that's the one that you'll need. Then you can hit select, and then you hit this blue create button down at the bottom. That will create the instance in a few moments. Oh, I hit cancel, so I'll just quickly create it, just so you see the whole process. Windows 2. I'll change this from Debian Windows Server, and I'll make sure to select one that has desktop experience. I'll keep the size of the drive to standard because I'm not going to install anything to it, and then I'll hit create. And this will take a little bit, but when it's ready, you'll see a green check mark. And now you can RDP just by clicking on the button that says RDP into the box. If you are on a Mac or a Linux computer, you can download the RDP file and use a local RDP client to connect. If you're on Google Chrome, there is a Google RDP extension that you can add so that you can get RDP access through the browser. But that is the basic steps on creating a Windows server. The similar steps apply to Debian, where you select a new instance. It'll take a little moment. You name it whatever you'd like. It already defaults to Debian, but you want to make sure that it is Debian 10. And then you hit create. And when that's done, you'll be given a different button that says SSH that'll give you an SSH client login, which is what we need for these labs. Now, like I said, within our Windows server, we want to get to this, the Windows Defender Firewall with Advanced Security. The easiest way is to type firewall, and this will pop up, the Windows Defender Firewall with Advanced Security. When we get there, we'll hit in the overview area, we'll hit Windows Defender Firewall Properties and turn the 3 main firewalls, their states, to off. With that complete, we can also verify that remote desktop is on because we are connected through RDP. And now we can check to see that our system, our Windows server, can communicate to our Linux system with ease. Easiest way is to bring up command prompt by typing CMD in the search, which will give us a command prompt. The IP address that we are going to ping is here in the Google Cloud Platform. So I am not using this system, so I'm going to get rid of it to alleviate any confusion. I'm using this Debian and this Windows. each machine has an internal IP address and an external IP address. These IP addresses change as the system is turned off and on, so they are not constant. But for this lab, I know internally within the Google Cloud Network, my Debian is this internal IP address, and the Windows the Windows box that I was showing you earlier is at this address. So if I want to verify that my two machines can talk to another, I will ping these addresses. In the case of my Windows box, I'll send a ping to my Debian 10.128.0.20, and I should get a response, and I do. So this shows my two machines are talking to one another. Awesome. I can also do the same thing from the Linux box, changing the address 10.128.0. My Google, is 19. And you see they respond one to the other. So we lowered our defenses in order to allow these two machines to talk to one another, which allows us to continue with this lab. If at any point I'm going too fast, please let me know. So now that we have that set up, we can begin our port scanning as we get closer to our first flag. On the Linux machine, we'll need to run these three commands. This third one we'll need to make some adjustments to. But to the first one, the first two we can run as is. So I will copy that command and paste it with Control-C, Control-V. Update all my repositories so I can download anything I need. While that works, I will copy the next line. Cool, it finished. I will paste my next line, which will install Nmap. And then we're going to run Nmap against a IP address. This IP address should be the IP address of your Windows machine. So for me, my address would be this. For you, it'll be different. So mine is still working. In this default scan, without any arguments, it'll scan the 1,000 most common ports. You should be able to see port 3389 open, and you'll get the answer to this flag. So again, on your system, on your Linux system, type sudo nmap, and then the IP address, the internal IP address of your Windows system. In my case, it's 10.28.0.19. In your case, it could be different. When Nmap is done, it'll provide you with an output similar to this that Sam has provided. And the answer to this flag, 410.1, is what's hidden behind the green box. So let me know if you have any questions. Okay, so once you solve this question, you can move on to the next two. that are at the bottom of the page. We're going to add some arguments into our search. So we can add a -A to do operating system detection. We can do -P to scan a specific set of ports, an SU to do UDP, as V to find version numbers. If we do a -P and a dash immediately, we'll scan the entire port range of 65,000. If we're going to do a scan of all the possible ports, you want to make that scan rapid. Otherwise, you will sit there for a good 20 minutes waiting for everything to finish. So I highly suggest adding this argument to your command. And we'll use this, the SV script banner, in order to grab banners which normally come out of a service saying, hi, I am SMTP, I am POP, I am whatever. In this example, we scan with -A for advanced, and we get the results of this scan. In these two questions, you are adding the arguments above, the correct arguments above, to find which port on this server, not yours, this is where things change. So instead of sudo nmap and your IP address that you got from Google, you're switching that to ad.samsclass.info, and you're searching for a service or a port that returns a banner called my packets are your packets. And then you'll look for another port at the same server that returns the banner, the key to the universe. When you find that port number, that is the flag to solve 410.2 and 410.3.